Greetings, dear colleagues, my name is Kirill Zakharov, and today I will present you our research work, so-called Realistic Control Time Series Generation with Variational Autoencoder. The control generation of time series facilitates the creation of scenarios for testing systems and models in unconventional situations, which is also useful for enhancing the model's generalizability. In this article, we presented an approach for realistic control time series generation based on variational autoencoder, so-called control VAE. In our study, we implemented four types of controls. The first is the start point control, which involves modifying the initial several points of the time series. The second is the end point control, which involves modifying the last several points of the time series. And we also can change the any value of time series at any time, which is so-called the value control at predetermined time. The final control mechanism involves modifying the overall dynamic of the entire time series, commonly referred to as trend control. This allows for simultaneous alteration of the dynamics at all points within the series. Our modified variational autoencoder model comprises enhanced encoder and decoder architectures. The encoder, similar to the standard VAE, transforms the initial time series into a latent representation. This representation encapsulates the mean and logarithm of the standard deviation of a normal distribution. The most significant modifications were made to the decoder architecture. The decoder takes Gaussian noise from the latent space, the label of the time series, and optionally the trend, starting and ending point, and value control point within the predetermined time as input. All components are processed in parallel and then combined to the main branch. The key concept of our work is to generate realistic time series. To achieve this, we integrate several masks denoted with the Gothic capital letter M into the architecture. These masks are constructed using exponential smoothing techniques and enable the model to process specific regions of the time series where control is implemented. Our model can be employed to generate control time series with various types of control, to conduct stress tests, for example, for financial or engineering systems. In the left figure, the endpoint control and value control are depicted. The value control is applied from the value -3 to 3 at time moment 100, and the endpoint control is applied from -1 to 0.2. The right figure illustrates the start point control range from -0.6 to 0.3. It can be observed that the time series remain realistic and retain their original local and global properties, while the control is integrated smoothly without unnecessary jumps. In addition, we have provided other examples where we applied the sine trend control, resulting in a complete alteration of the dynamics to a sine wave. In the right figure, we applied the upward trend control, demonstrating that the dynamics can still increase while preserving the initial characteristics of the time series. Thank you for your time. Our code is available on GitHub.